now because I have tangent theta, which is this over this, 2 the square root of 2 over 3, flip 3 over 1. So this is 2 the square root of 2. Cotangent theta must be 1 over this, mandatory. I rationalize, and I get the square root of 2 over 4. Secant theta must be 1 over cosine, flip. And cosecant theta must be 1 over sine, flip. And rationalize. So 3 the square root of 2 over 4. So it's always easy when I'm given sine or cosine. It's easier in the other situations too. We're going to get to that in a minute. So I was given cosine, and I determined sine using this identity. But also I needed to analyze. You can say you don't need to analyze anything because we're talking about the right triangle. So they are acute angles, and they all have to fit in the first quadrant. I agree, if you say that. I wanted to show this idea because it will come back and we'll talk about it again. So the sign of the trig functions in each quadrant. Both are positive. Here sine is positive, cosine is negative. Here they're both negative. And here cosine is positive, sine is negative. We need to remember this forever. You're going to see where we apply it again. Okay, and now what about not using identities? Okay, fine. So we're given cosine theta equals 1/3. Fine. There must be a right triangle with an acute angle theta whose cosine is the adjacent over the hypotenuse. So we are given cosine theta equals 1/3. There is a right triangle with an acute angle theta whose cosine is the adjacent over the hypotenuse. Okay, I need to determine this leg. I have to use the Pythagorean theorem. 9 squared equals 1 squared plus x squared, or x squared plus 1 squared equals 9, 3 squared. So x squared plus 1 equals 3 squared, which is 9. So then x squared equals 8. I have to take the square root, and I have 2 the square root of 2 with plus or minus, and I have to say no, it has to be plus because it's a distance in a triangle. Okay, knowing that, then the triangle becomes this, 1, 3, 2 the square root of 2. So I have sine theta opposite over the adjacent. And so on and so forth. Everything else follows as we just did. I got that sine is 2 the square root of 2 over 3. Any questions? So this is with triangle with a definition, basically. And this method is, you don't have to think about this because it's all in a right triangle, so they have to be positive. I just wanted to have this analysis because we're going to look at it, and having exposure to it more than once is perfect. So sine squared plus cosine squared equals 1. We determined from this identity, we determined sine. And once we had sine, we built everything else quickly. Okay. Would you like to see another example? Would you like to work on another example?
Yeah.
Okay, so let's choose. Would you like to choose, or I will?
You can choose.
Okay. What about 34? Secant theta equals 5/3. Okay. There exists a right triangle with an acute angle theta, whose secant is 5/3. What will you denote by 5? What will you denote by 3? Remember that this is 1 over cosine. Anyone, please?
5 would be the hypotenuse.
So cosine, so this will be, if secant is 5/3, so this will be 3/5. I completely agree. And which one is 3? The opposite or the adjacent?
Adjacent.
Yes. Since these are Pythagorean numbers, what is this? With no calculations?
4.
That's it. So now we have everything else. So we have that cosine theta equals 3/5. We have that sine theta is, we have that tangent theta is, cotangent theta is, and cosecant theta. Can anyone give us sine? Can anyone give us sine, please?
Four over five.
Perfect. Can anyone give us tangent?
Four over 3.
Perfect. You don't have to think about this. It has to be the multiplicative inverse of tangent. How much? How much is cotangent?
3/4.
Of course. And finally, cosecant. Remember, it starts with C. It has to be 1 over this. Cosecant, 1 over sine. What will that be?
5/4.
That's it. How do we feel about this type of problem? Are we okay? Moving on. Please help. Can we move on?
Could you
Yes?
explain the previous page, like the identities?
Yes.
Because I'm still kind of confused with the circle and
Yes. So the circle basically was used only to identify the sign. This, not the sign, but the sign. So I use the circle just to explain which of these two we pick. And as I said, this is a little bit redundant because, of course, in a right triangle, all angles have positive values for their trig functions. But I just wanted to expose you to this idea of where we measure from early on, where we measure sine, where we measure cosine. So sine is measured on the y-axis. So in other words, these two quadrants, sine is positive because the y-axis is positive here. Sine again is measured on the y-axis, so this portion will give us sine which is negative. In other words, if an angle starts here and ends here, must have a negative sign. If it starts here and ends here, must have a negative sign. Similarly for cosine. Cosine is positive here because it's measured on the x-axis, and it's negative here because again it's measured on the x-axis. This is the negative side of the x-axis, this is the positive side of the x-axis. So cosine is positive, but you could have said, but sine could be positive or negative because look, cosine is positive, sine is negative. True. But this angle would not fit in a right triangle. So in this situation, in a right triangle, all trig functions are positive. So we had to choose the positive value of sine, not the negative. You'll see what happens later when we talk about angles that are do not have the terminal side in the first quadrant. So this analysis is important. I wanted you to be exposed to it from the very beginning, but it's more important a little bit later in chapter 5 and beyond. Is this better?
Yes, thank you.
Perfect. Good. Moving on. Do we want to choose another or we move on? Help, please. We move on or we choose another?
Can you do another one?
Yes, please. Can you please choose anything? Would you like to choose or you want me to choose? It doesn't matter.
You can choose.
Okay. So we had the previous one was 34. So we used one. Yes, go ahead.
What the section are we on? Are we on 5.2?
Correct.
Okay, thank you. That's it.
Sure. So would you like to choose or you want me to choose? So we
No,
looked
you
at,
can choose. I just wanted
okay.
to know
We
what
looked at
section.
an example with cosine. We looked at an example with secant. Let's look at an example with tangent. So we have tangent theta equals the square root of 2. Okay. So we have a right triangle with an acute angle theta whose tangent is the square root of 2 over 1. Everything is over 1 if it doesn't have a fraction or a denominator. So then what is the square root of 2 and what is 1 in this triangle? What is the opposite leg?
Square root of 2.
Excellent. And then you're going to say that the adjacent is 1. We do have to determine the hypotenuse. I'm going to call it x for now. The hypotenuse is determined by squaring a leg plus squaring the other leg equals the hypotenuse squared. So x squared equals 3. I should take the square root and write plus or minus the square root of 3. You can say, wait a minute. It cannot be. It's a distance. So in this case, x is the square root of 3. Once we identify that, the only step is just identify sine theta, cosine theta, cotangent theta, which is extremely easy, secant theta, and cosecant theta. So can anyone give us cotangent right away without thinking?
Square root of 2 over 2.
So it's 1 over the square root of 2, so which is the square root of 2 over 2. Excellent. Can anyone give us sine from the triangle? Anyone can give us sine? Anyone, please? Sine? Is anyone with me?
The square root of 2 over the square root of 3.
Thank you very much. We rationalize the square root of 6 over 3. Perfect. Cosine. Can anyone give us cosine? I'm going to write it here because I don't have enough room.
One over square root of 3.
Yes, indeed, 1 over the square root of 3, which is the square root of 3 over 3. Excellent. Secant. It starts with S. It must be 1 over cosine. And of course, you're going to flip this. So you don't need to rationalize.
Square root of 3.
That's it. And cosecant, it starts with C, is 1 over S. So we have to flip this. But we have no choice, and we will have to rationalize it by the square root of 6. So 3, the square root of 6 over 6, and we will have to simplify. The square root of 6 over 2. Good. I think we can move on. Agreed? Okay. Use fundamental identities and or the complementary angle theorem to find the exact value of each expression. Do not use a calculator. So let's choose. I would like to start with, I wrote down 47. I don't remember why I wrote it down. 47. But you can choose any, and we can start with that. Anyone would like to choose, or I will. Okay, I will start with 47 then. And we have 1 minus cosine squared of 20 degrees minus cosine squared of 70 degrees. Okay. So we want to simplify. Allow me to start a new video.